Once again, good afternoon. Um, the purpose of this class is not necessarily to replace the learning curve, but to assist you by simplifying concepts in physics tailored towards UTME, meaning that we are going to actually be discussing and simplifying core UTME syllabus according to physics. So we are not just going to be reading and miss. We are going to pick this topic based on how JAM usually set their questions and try as much as possible to break it down in a simple manner that anybody will understand. So that's why I said the purpose of this guide is not to replace your learning curve, but to assist you by simplifying concepts in physics towards UTME. So let's start. What then is physics? We're going to be looking at what is physics. It's very important. Physics is basically the study of things around us and how they work. So physics means we are investigating how things go around us and how they work. Take for instance, we have why a ball falls down when you throw it up. That's physics. You want to investigate why does a ball fall down when you throw it up. So something has to be in process that every time you throw a ball or anything up, it falls down. Gravity. Why does a fan move here? So every time you try to study things around you and you understand why they are happening, basically that is physics. To understand physics, we must measure things. To understand physics, we must measure things. And in the course of measuring things, that's where the word physical quantity comes into play. Physical quantity, that's where it comes into play. So every time we measure something, understanding why we measure it is called physical quantities. So we'll be treating what then is physical quantity. A physical quantity is anything we can measure and it will give you a number. Anything we can measure and it will give you a number. So if you can measure it and it gives you a number, it is physical quantity. Let's look at the example, the length of a table. So we find the length of the table is going to give us a number. The weight of a bag, as long as it's going to give us a number, it is a physical quantity. The time spent in class, as long as you can measure the time spent in a class, is a physical quantity. Temperature of water, height of woman, speed of a car. Anything that you can measure is called physical quantity. Please take note of that. What are the types of physical quantities? There are basically two types of physical quantities you must know in physics, and you must always memorize it towards exam in JAM. So physical quantities are anything that we can measure and can give us numbers. The two types of physical quantities are what we call the fundamental quantity or base quantity. Fundamental quantity or base quantity. They do not depend on any other quantity. Just know it. Anything that is called fundamental quantity does not depend on any other quantity. Anything that is called fundamental or base quantity does not depend on any other quantity. The other type of physical quantity is derived quantities, meaning a derived quantity is made up of two or more fundamental quantities, meaning that a derived quantity is made up of two or more fundamental quantities. Take, for instance, what I've been saying, the types of physical quantities. Anything that you can measure that will give you the resulting number is called physical quantities. And there are two types. The fundamental quantity, which means it does not depend, the fundamental quantities don't depend on other quantities. But derived quantities is a combination of two or more quantities, fundamental quantities. Is a combination of two or more fundamental quantities. We are going to be looking at the example in few seconds now. We are going to be looking at the examples in few seconds. Types of physical quantities. We have been able to identify that we have fundamental quantities and derived quantities. Fundamental quantities does not depend on any other quantity, while derived quantities consist of two or more fundamental quantities. Let's look at examples of fundamental quantities that you must take note of. There are 7 fundamental quantities. Look at it. Remember, whether it's a fundamental quantity or derived quantity, they are classified under physical quantities, meaning they can be measured and it will give us number. Why fundamental quantities does not depend on any other quantity, derived quantities depend on two or more. It's like the combination of two or more fundamental quantities. So the 7 fundamental quantities you must know. Very important. That's why I've written it down there. Length, meaning how long, and the SI unit for length is what? Meters. And the symbol is M. We have mass. Determine how heavy. The SI unit is kilogram. And the symbol is kg. We have time. Time is a fundamental quantity. It does not depend on any other quantity. It tells us how it takes, and the SI unit is seconds, meaning the symbol for it is S. We have what is called temperature. Determine how hot or cold. The SI unit is Kelvin, and the symbol to represent it is K. Another fundamental quantity is electric current. This determines the flow of electricity, and the SI unit is ampere, represented by the symbol A. We have another fundamental quantity, luminous intensity. It determines the brightness of light, and the SI unit is candela, represented as symbol CD. Another fundamental quantity is amount of substance, meaning the number of particles. The number of particles, and the SI unit is mole, represented with the symbol MOL. These are the 7 fundamental quantities. Please take note of it. If you have to memorize it, try as much as possible to memorize it. Length, mass, temperature, electric current, luminous intensity, amount of substance. Know the SI units. The SI unit, please know the SI units. Meters for length, kilogram for mass, time, seconds, temperature, Kelvin, electric current, ampere, luminous intensity, candela, and amount of substance, mole. Now, having said the 7 fundamental quantities, let's look at derived quantities. Recall, in the course of this lesson, I said derived quantity is a type under physical quantities, and derived quantities are quantities that is made up of two or more fundamental quantities. Please don't get it wrong. Fundamental quantities does not depend on any quantity, while derived quantities are quantities that comprises of two or more fundamental quantities. So let's look at an example. Area is a derived quantity. Length, let's look at it. Length and breadth. Length and breadth are fundamental quantities, just like the definition that every derived quantity is made up of two or more, and meaning length is represented in meters, breadth is represented in meters, and meter times meter will give us meter squared. That's why it's a derived quantity. We have volume. Volume is a derived quantity. Volume is a derived quantity because the formula to calculate it comprises of two or more fundamental quantities. Let's look at the formula to calculate it. Length multiplied by breadth multiplied by height, and meter times meter times meter will give us meter cube. Speed is also a derived quantity. Speed is a derived quantity. The formula to calculate it is distance divided by time. Remember, derived quantity comprises of two or more fundamental quantities, and time is a fundamental quantity, distance is a fundamental quantity. The unit is meter per seconds because distance is calculated in meters and time is calculated in what? Seconds. So meter divided by seconds, and that's why we are having this here. Density is a derived quantity. Any quantity that has two or more fundamental quantities. And look at it. We have mass, which is a fundamental quantity. We have volume, which is a derived quantity, and the formula to calculate it is kilogram divided by meter cube. Remember that mass is measured in kilogram. Mass is measured in kilogram, and volume is measured in meter cube. So we're having mass divided, kilogram divided by meter cube. So quickly, I want you to note that any quantity that consists of two or more fundamental quantity is called a derived quantity. We have an example here. An example here for practice. Example, if a boy walks 10 meters in 2 seconds, we should find the speed. Here, 10 meters represent distance and 2 seconds represent time. Going by the formula that speed equals distance divided by time, then you are going to say 10 divided by 2, meaning that the answer is going to be 5 meters per second. Please, if you see an option of 5, it is wrong. Every question will require its SI unit. So if you see an option of 5, you might have gotten it wrong. That's mathematics. But without the SI unit, which is meter per second, it is wrong. So that's why I'm having 5 meters per second. What is units? Is the next thing. I told you that we are trying to look at the syllabus for JAM, where they actually center their questions on. What are units? A unit tells us how much of a quantity we have. Before going further, when we have money, we have different denomination of Nigerian money. We have 5 naira, 10 naira, 20 naira, 50 naira, 100 naira, 200, 500, 1,000. There is a proposition for 5,000 naira. So it tells us when you have 5 naira, it means you have 1 naira in 5 places. I'm just using that as an example. So a unit tells us how much of quantity we have. It's very important. Take for instance 5 meters. The unit there is meter. That means 5 meters is talking about 5 meters in terms of distance. Or if you are using a ruler to measure something, you will see 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter. It tells you the length of whatever you are measuring. The centimeter there represents the units. Another example here is 10 seconds. The unit there is seconds. It's telling us that the duration spent is 10 seconds. The duration spent is 10 seconds. So if you are running and you are run for 10 minutes, the unit there, the 10 minutes, the unit there is minutes. You are run for 600 seconds. Please take note, it's very important. Without units in physics, numbers are meaningless. Without units in physics, numbers are meaningless. And I gave an example when I was in the previous slide, when I was talking about 5 meters per second. I said, even if you got the answer as 5, without the SI unit attached to it, the answer is wrong. These are things you should take note of anytime you are answering question in physics. So by saying the rope is 5 is wrong. The rope can never be 5. The correct answer is the rope is 5 meters long. The rope is 5 meters long. So much for that. Now let's look at the SI unit which is very, very important. What is called SI unit? SI unit is the International System of Units. It is the International System of Units. Just like our Naira is the appropriate means of buying things in Nigeria. If you go to Ghana, the appropriate money used to buy things is cedis. If you go to Benin Republic, the appropriate money used to buy things is CFA. If you go to United Kingdom, the appropriate money to buy things is pounds. United States of America, dollars. In Germany, Spain, euro. So these are what is generally accepted to purchase things over the world. Now, once it comes to SI unit refers to International System of Units. Meaning these are the standard units used all over the world. They are the standard units used all over the world. So let's look at common SI units you must memorize. It's very important. Length, you must know that length is measured in meters. Mass, you must know that mass is measured in kilogram, not gram. You can convert, questions might come in gram, but the standard way of measuring mass is kilogram. Time. The standard way of measuring time is seconds. So even if you see a question that says the time spent is 2 minutes, it is expected that you convert that time duration to seconds, except otherwise stated in the question. We are looking at temperature. The SI unit for temperature is Kelvin, but questions might come where you see temperature being the question might present temperature in Celsius, and they ask you to give your answer in the SI unit for temperature. Please know that the SI unit for temperature is Kelvin. The SI unit for temperature is Kelvin. The SI unit for current is what? Ampere. The SI unit for current is ampere. Also take note of the measuring instruments. Like for length, we can use ruler. We can use a measuring tape. For kilogram, we can use balance, like weights. For time, we can use clock or stopwatch. For temperature, we use thermometer. And for current, we use ammeter. So please take note of the SI unit used all over the world. SI unit is the global standard, and it's important that we take note of those things. So let's look at scalar quantities. Please, in the course of starting this lesson, I said physical quantities are quantities that can be measured and they give results in numbers, and physical quantities are divided into two or classed into two, where we have the fundamental quantity and the derived quantities. The fundamental quantities are quantities that doesn't depend on any other quantity, while derived quantities are quantities made up of two or more fundamental quantities. At the end of this lesson, I'm going to share a video on this Telegram channel for you to watch again for easy understanding. But then, let's look at scalar quantities. Very simple explanation, not clumsy. Like I said, the purpose of this lesson is to simplify basic things and syllables in such a way that you are going to understand. What is scalar quantities? Scalar quantities are quantities that just have size. They only have size alone. They only have size alone. Just size. Weight of human being, that size. Weight of human being, that size. Length of a table, just that size. So let's look at it. Example is mass. Yes, they have no direction. They have no direction. Example is mass, time, temperature. They don't have direction. So what it is important you know that scalar quantities just have magnitude and no direction. And for easy understanding, take note that magnitude refers to size. And we have given you simple example. So every time you look at a quantity, questions do come. I'm going to ask one or two questions at the end of this lesson. Questions do come on scalar quantities or difference between scalar quantities and vector quantity. But at present, we are discussing scalar quantities. Scalar quantities just have size, no direction. A typical example is time. Time is measured in seconds. Temperature is measured in Kelvin. Mass is measured in kilogram, and they have no direction. The other type of quantity is now what is called vector quantity. A simple explanation. Like I said, this lesson is not to replace your teaching in school. It is to assist you to simplify this key concept according to JAMB syllabus. What is vector quantities? Vector quantities have magnitude and direction, meaning it has a size and it has what? Direction. Every quantity that has a size and direction is called vector quantity. Let's look at this example. Force. When you say force, you push something, you are applying force. Definitely you are pushing something towards a direction. Yes or no? It becomes vector quantity. When you say velocity, a car is moving at a velocity of 20 meters per second. Definitely the car will have a direction. Displacement, please take note of it. The difference between displacement and distance is that displacement has direction, and that is why it is called vector quantity. So in vector quantity, direction matters. The difference between vector and scalar quantity is that scalar quantity has only magnitude, no size. Only size, no direction. While vector quantity has size and magnitude. Example, when you say 10 meters, that's scalar. It has no direction. 10 meters is scalar. It's just this, that's distance. We are talking about distance. When you say scalar, that's distance. So here it is referred to as scalar quantity because it has no direction, but it has size, which is 10 meters. But when you now say 10 meters to the east, it becomes displacement. It is a vector quantity because you have specified the direction. Please, questions do come this way. when you are going to be asked 10 meters to the east is a vector quantity, yes or no? Yes. Once it has magnitude and direction, yes, it is a vector quantity. Once it has magnitude and direction, it is a vector quantity. So, quick revision. Physical quantities are quantities that can be measured and gives you numbers as a result. Units give meanings to numbers. So the unit of time is seconds. For mass is kilogram. For temperature is Kelvin. Please take note of it. SI units are international standards. SI units are international standard. That's why I gave you an example that the currency accepted in Nigeria is Naira. In Benin Republic, Sefa. In Ghana, cedis. In United Kingdom, pounds. In USA, dollar. But the currency that is generally accepted all over the world, anywhere you go, if you want to pay in that currency, is going to be accepted, is dollar. If you take dollar anywhere, it's going to be accepted as a means of payment, either via card or currency, via transfer or cash. So every time if you don't remember the meaning of SI unit, please remember that SI units are international standards. What a particular unit is measured with all over the world, and time is measured in seconds, temperature is measured in Kelvin, mass is measured in kilogram, whether in Nigeria, whether in Europe, whether in North America, whether in South America. Please, fundamental quantities are basic quantities, are quantities that do not depend on other quantities. And we have time, we have temperature, we have length, we have breadth, we have mass. Derived quantities are quantities that come from a formula. It will consist of two or more fundamental quantities. So take for instance, we said the area of a rectangle, it consists of two or more fundamental quantities, which is length multiplied by breadth. And you must not forget the unit, which is meter per second. So having quickly done a summary, let's ask ourselves some tests. Which of the following, like practice tests, which of the following is a derived quantity? Remember, you must know the meaning of derived quantity. These are quantities that are based on two or more fundamental quantities, and it is only achieved through a formula. When we are looking at the answer here, mass is a fundamental quantity, time is a fundamental quantity, length is a fundamental quantity, but velocity is not a fundamental quantity. It has to do with speed and time. It is derived. Another question, the SI unit of force. What's the SI unit of force? Like I said, that's the international standard. The SI unit of force is Joule. The SI unit, the SI unit of force is Newton. Is Newton. The SI unit for power is watts. But for this question, the SI unit for energy is Joule. So the SI unit for force is what? Newton. Newton, what is generally acceptable all over the world. Which instrument is used to measure electric current? So we are talking about voltmeter, thermometer, ammeter, barometer. So voltmeter is used to measure volts. Thermometer is used to measure temperature. Ammeter is the correct answer. It is used to measure electric current. While barometer is used to measure pressure. So the answer to this question is ammeter. They said density. What is density? What is density? Density is defined as, now density is a derived quantity, and it has to do with mass divided by volume. The SI unit of temperature, like I said, is what? We have Celsius, we have Fahrenheit, we have Kelvin, we have Joule. Remember that the SI unit for temperature is the international standard of measuring temperature all over the world. And the answer is what? Kelvin. Thank you for actually listening and watching this. Our next class on physics will be, the next topic we'll be discussing before the week comes to an end will be motion and Newton's law of motion. So peradventure you have any question to ask me, you can actually chat me on via Telegram, via this number, or my personal mail. I will drop this tutorial on the platform so that you can rewatch for easy understanding. Thank you for watching.